Okay, in this next example, we can see that there are a couple of major differences to the last one that we did. So first off, this equation has a 2x inside the bracket, which is perhaps a little bit daunting. Also, we have a pretty weird looking domain to solve over. So, you know, those are two things which are going to throw some people with a question like this. The thing that I'd like to point out is that this says x is an element of this domain. Now, what we actually have over here is 2x, it's not just x. So one of the first things I'm going to do is I'm going to just change that domain so that 2x is an element of, and this is going to make it a little bit nicer, and it's going to make it so that we know which domain we need to get our angle in before we sort of rearrange the equation. So if I multiply the domain by 2, it's actually just going to become negative pi to pi. So the other thing that's a little bit nasty there is the fact that we're going into a negative angle. Now, again, it comes back to knowing those exact values. So the exact value for the cos function, which gives a solution of 1 on root 2, should be pi on 4. So I'm going to write that the basic angle is pi on 4. Notice I'm not drawing a diagram yet, okay? This is the first quadrant angle, and the problem is that in the first quadrant cos is always positive. So we need to find where cos is negative, okay? You might be familiar with the diagram. It has A, S, T, C, just like this. So cos is going to be negative in the left-hand side, where only sine and tan are positive, okay? So we're looking for a second quadrant and a third quadrant solution. So in the second quadrant, we're going to do pi minus the basic angle, because we're working backwards from the value of pi. And pi minus pi on 4, it's pi minus a quarter of pi, is 3 pi on 4. Okay, that's our solution in quadrant 2. Now, I don't actually need to calculate a quadrant 3 solution because that would be going past pi. So there's no need for me to actually do that. Instead, I need to consider what would happen if I were to go backwards around the unit circle. Okay, so I'll go backwards to some place over here, and it's like the third quadrant, but it's working backwards. So we're going from 0 back to negative pi, and it would be if we had the negative pi plus that same basic angle. So the quadrant 3, or quadrant negative 2, I guess you could call it, it's a little bit of a weird sort of situation. In this case, I'm just going to call it quadrant 3, okay? We'll use negative pi, and then we're going back in the positive direction, so we're going to add on that basic angle. And when we solve that, negative pi plus pi on 4 is negative 3 pi on 4. So what we can say is that that angle inside the cos function must be 3 pi on 4 or negative 3 pi on 4. So 2x, which is that angle, is 3 pi on 4 or negative 3 pi on 4. Those are the only two possibilities within the suitable domain. And there's only one step left to do here, which is to get x by itself. So we can divide both sides by 2, and we're left with x equals 3 pi over 8. When we divide a fraction by a number, the number essentially gets multiplied with the denominator. And the other solution is negative 3 pi over 8. You might actually prefer to write that as x equals plus or minus 3 pi over 8. Not required that you do that, but it's just a nicer way for some people to write that. Anyway, leave that video there. Thanks, guys.